Hi everyone, welcome back to our channel. Let's try to solve this problem. The problem given is find the values of R1 as well as R2 for the network shown below. So this is a single closed path. That's why this is called circuit 1. This is another closed path. Group of circuits is called as a network. Now is asking us find the values of R1 and R2. The voltage at this point is 110 volts. Okay, so automatically a resistor is there. This will create one more new node. I'm labeling this new node as 0 volts. Automatically the voltage at this point and the voltage at this point both are same. This will also create an voltage of Vx. Now let's try to find the total current. So how to find the total current is apply KCL at this point. Okay, so by applying Kirchhoffs current law at this node, you can find the total current. I am assuming this total current as I. So current I is entering. You can see here current I is entering and it is leaving as 4 amperes in this branch and 6 amperes in this branch. Therefore, the value of I is nothing but 10 amperes. So that therefore the value of I is equal to how much now? 10 amperes. So now I'm going to apply nodal analysis and I'm going to solve this problem. So current in this branch, how to write down the current? Current I is equal to V by R. So what is the voltage at this point? This is positive terminal, this is negative terminal. Okay, so how the current flows? The current is 4 amperes is equal to, so current is flowing, what is the leaving terminal? Plus Vx. Okay, and current is leaving, what is the leaving polarity? Minus 80. Okay, divided by R. R value is nothing but how much? R1. So I can write down R1 is equal to Vx minus 80 by 4. This is the part 1. So similarly in this branch also apply nodal analysis. Current I is equal to, we can write down it as V by R. So what is the current in this branch is nothing but 6 amperes is equal to V by R. Okay, so how to write down this one is current is flowing. Okay, whenever the current is leaving, or the leaving polarity of the voltage? Vx, and it flows like this. The leaving terminal is how much? Minus 50 divided by, what is the resistance of this branch? Is nothing but R2. So therefore the value of R2 is equal to Vx minus 50 divided by 6. So ultimately we can get R1 and R2 only when we know the value of Vx. So I want to link this drop and this drop. So all the voltages can be added just by applying Kirchhoff's voltage law, KVL. So current of 10 amperes is flowing, or the leaving terminal we have, which is nothing but plus 110 volts, and current is leaving. What is the magnitude of the current in this branch? So current is leaving, it will enter as positive and it will leave as negative. What is the leaving terminal of the voltage? Minus I into R. I is how much? 10 amperes multiplied with what is the value of resistance offered here? 2. And it leaves here, what is the polarity of the voltage? What it is going to leave is minus, which is nothing but minus Vx is equal to 0. So from here I can write down 110 minus 20 is equal to Vx. Therefore Vx is equal to 90 volts. Substitute the value of Vx here. Therefore R1 is equal to 90 minus 80 by 4. Next one, the value of R2, 90 minus 50 by 6. Simplify this value. The value of R1 is nothing but when you solve it, you're going to get it as 2.5 ohm, and the value of R2 you're going to get as 90 minus 50. Okay, so you can solve it directly in the exam by using calculator also, so there's no issue, no, try to do by hand. So 90 minus 50 is 40, divided by 6. Okay, it is around 6.6 ohms. That is how to obtain the values of R1 and R2. So successfully we had find the value of R1 is equal to 2.5 ohm and R2 is equal to 6.6 ohm. So just by watching this video, nothing you can get. Just what you have to do is you should take a calculator and you have to parallelly solve. Then only you can understand better. Okay, so hope you're able to understand the problem. If you feel the content is useful, please like the video, share to your friends. If you have any doubts, let me know in the comment section. Thank you for watching, and if you're watching the channel for the first time, subscribe to my channel. This is a free channel for the development of students and faculty. Thank you for watching. Yours obediently, Ram.